Recordings rolling. It is Friday, September 5th. I have returned your quizzes to your current folders. Like I probably picked this up already, and all your other assignments. So everything that I had turned in as of end of yesterday has been graded, returned. Here's what we're doing for quiz corrections. If you missed anything and you want partial credit back, then whatever question you missed on a separate page of paper, show how to get to the correct answer. A lot of these are like you set up some equation and solve the equation. So if you miss something that's equation based, solve the equation. If there's a graph question that you missed the graph, draw the correct graph on a separate page of paper. There might occasionally be something that's conceptual that maybe you can more answer in sentence form, like why something is, or so something like that. But if you do that, any question you miss, if you write on a separate page of paper, show me that you know how to get to the correct answer, and staple your quiz to that, turn that in, then I'll give you partial credit back. Right, so any questions about quiz corrections? Yeah, was that
not like any grades?
yeah. Unless you got 100 or anything. Yeah. So if you got like a 90, yeah, you can get a few points back. Yeah, that's right. STEM flyer. So there's this STEM plug. Looks like it's Mondays after school. It's your Gentleman's class. So if you're interested in that, here you go. Now, here's what I promised you guys is I would give you guys today to work on your puzzles. You guys remember I assigned these puzzles to you guys from lessons 1, 1, 1, 2, 1, 3 that are due on Monday? You guys remember that? Okay. So we gone over these last 3 days. So you can work on these today. You can work on your quiz corrections if you want to do quiz corrections. If you have any questions about, like you really don't know how to solve it, call me over. I'll help you out. If you want to work on Alex today, that's okay too. Okay. You guys have one more thing. So in my physics classes, we've been doing this activity that I thought, oh, you know what? My algebra students might be interested in doing this. So I'll let you guys do this if you want. But let me show you guys the premise of this, and if you want to do this, then we do this. So reaction time. Guys, do you think there's a mismatch between what's happening in reality and your brain perceiving what's happening? Yeah. Like if the deer steps out in front of the car, you're driving the car. Do you immediately step on the brake, or does it take you a tiny fraction of a second to recognize that the deer's there? Right. Yeah. Right. Okay. So, see, how could you get reaction time? Do you, like, what's a simple experiment? And you probably don't want to use a stopwatch because the error using stopwatch is sort of what we're trying to figure out in the first place. So, stopwatch is no good. Okay. But what about I got a couple of friends here. Do you have some friends? Do you guys have some friends?
No.
Well, we can't do it. Well, you better find some friends for this. Say you're holding a ruler and your friend has their fingers down here at the 0 centimeter mark, 0 centimeters, and you drop the ruler. Then, by the time your friend catches the ruler, let's say they catch it like 17 centimeters, for example. Right? Do you think that the amount that the ruler has fallen could effectively tell you how much time it's been falling for? Like, there's some amount of time it takes to fall some distance. You guys get that?
Yeah.
Okay. Now, guys, what's pulling the ruler down?
Gravity.
Gravity field, right? Right. And guys, what is gravity field? Let's say, is the ruler falling at constant speed, or is it speeding up?
Speeding up.
Speeding up? How many of you think the ruler is speeding up as it's falling? I think so. Yeah, I think it's going faster, faster, faster. Okay. Does anybody know what the physics word for that is? If it's speeding up?
Velocity.
Acceleration. Aha, acceleration. Yeah, it is accelerating. And acceleration due to a gravity field is this lowercase g right here. Okay. So now in my physics class we'll do a little bit more setup, but for you guys, I just want you guys to see this equation. So h could represent the height change of the ruler, like how far the ruler's falling. You guys get that? H is how far the ruler's falling. G is the gravity field of the planet. You guys can imagine different gravity fields. Like if we were on the moon, do you think this would fall down more slowly?
Yeah.
And maybe on Jupiter it goes really fast. So we're on Earth. We're in Earth gravity. I'll give you guys a number for that pretty soon. Okay. Okay. So it turns out anything that would be accelerating takes this type of equation. Okay. Actually, you guys could graph this. Because if you graph height as a function of time, what shape does that make? You guys should know that.
Parabola.
Parabola. It's definitely going to be a parabola, isn't it? So height is a function of time. What would make a parabola shape? Okay. Now, next challenge for you guys. Can you solve for this t? Because that's the question. Is reaction time. Like, what is your reaction time as a function of how far is the ruler falling? Because how algebraically do you solve for that t right there? How do you get t? First, you have to do what?
Where?
Okay, you want to solve for t. Guys, I need a series of algebra steps. And the last step says t equals something. there's a funny looking expression. First, you have to. How do you solve for t?
Divide by 2.
How about cross multiply the 2?
Oh, yeah.
Guys, cross multiply the 2, so now I got 2h. Then do it.
Subtract an 8.
Guys, you guys really should know how to do this. Guys, I'm trying to solve for t in terms of these other variables.
Oh, so you.
Cross multiply the 2.
Mm-hmm.
What do you do with this g?
Subtract.
Do you subtract or divide?
Divide.
Divide. Divide it. Okay, so that's the next step right there. Okay. No, that's not t yet. That gives you t squared. You guys get that? Times 2 divided by g. Okay. I still just want t by itself. So what do I still have to do? Take the square root. Yeah, square root. You guys see that right there? Okay. So, yeah, what the class been doing then is they've been pairing up, like dropping the roller and catching it. Suppose they do like 3 trials or something like this, like trial ABC, like that. Okay. They say how far does it fall in centimeters? We're going to use metric. Right, so let's say centimeters. Okay. You can calculate the time, but you have to know one more thing. You have to know what this g is. So here I'll give that to you. Actually, does somebody know? Does somebody happen to know what g is on Earth?
No,
Like a number for it?
Right.
There's different values. In feet, it's like 32 feet per second squared. Okay. In the metric system, they usually call it 9.8 meters per second squared. Right. But I'm not going to have you use either of those numbers because the markings on the ruler are in centimeters. Guys, how many centimeters are in 1 meter?
100.
100. So in terms of centimeters, like if I want not meters, but
908.
there you go. That's it. It's 980. Okay. That's what goes into this G. So to give you guys an example, suppose I caught this at 17 centimeters. Okay. I went in the calculator. Okay, show you guys a calculation here. I'm just following this expression right here. I pull up a square root. So do square root. 2 times the height fall. So 2 times, okay, that would be 17 centimeters. And then divide by the number 980. That's what he said. Okay. Oh, I should have asked you guys. Do you guys know what a pretty average human reaction time is?
Like 2.
Yeah, 0.2 seconds. Yeah. How do you know that? I don't know. How do you guys do these things? Yeah, 0.2 seconds. So if you get some, hey, is that pretty close to 0.2 seconds?
Yeah.
0.186?
Above average.
Yeah, pretty close, right? Yeah, I get to catch it at 17 centimeters. Yeah, maybe a little faster than average. Pretty good, right? So, I had my last class go if they want to choose or not, but actually they had a better idea. They said, let's just go ahead and I'll give you guys a half page so you can make a table and do this. And then if you don't want to do it, I'll just give you an exempt in the grade book. So if you do it though, it'll be extra credit. So here, help you guys set up this table. So if you want to do this as I'm doing it. So here's your extra credit opportunity. So write your name. This is for extra credit. It's called reaction time activity. You can make a table. Just like my table. Let's do different trials. Maybe trial 1, trial 2, trial 3, or ABC, whatever you like. We're going to say how far is the roller fall? I'm going to call it H for our height change. This is going to be in some number of centimeters. And what's the corresponding time that would be in seconds? Now, the centimeters you can either observe or measure.
Yeah, so funny.
Right, so that's where you get with a friend. So basically, the picture here. Right, so one of you holding the roller, one of you has the fingers at the 0 centimeter mark. Then surprise let go of the roller, and this other person catches it as fast as they can. And the time in seconds you calculate. Okay. And remember, time in seconds is equal to square root of 2 times the height fall divided by the gravity field. Now, height fall, just go ahead and put it in the number of centimeters, like 17 centimeters, for example. And for gravity field, it's 980 centimeters per second squared. Now, in the calculator, you don't write the units. You just put 980. Right, so that would be 2 times 17 over 980, and then take the square root of that. Okay. And yeah, your reaction time should be in the ballpark of 0.2 seconds, plus or minus a little bit. Okay, so there's your extra credit. There's your extra credit activity. If you want to pair up with somebody and do that. So you're either doing that extra credit activity, or you're working on your puzzles that are due Monday, or you're working on your quiz corrections, or you're working on Allen's. So you guys got lots of opportunities. It's gonna be a good weekend.